So, will the SAT have exponential functions? I'm glad you asked. It's your girl Tiffany from Tiffany's Tutoring and Consulting LLC, guiding you through these SAT education streets. All right, so yes, there will be exponential functions. I'm again working from the free test 4 from SAT College Board, giving you some of the exponential problems you may see on the test. Okay, so let's look at the first one, 16. It gives you a function. Now, let's back up a little bit. When I'm talking about exponential functions, this is the form you typically see exponential functions in. A is your starting value, B is your growth or decay, and then the X is an exponent. That's exponential. And that's typically in years, but it's typically time. You just have to be careful for what they tell you in the problem. So it gives you a function here and it talks about a bank account and it's going from 1957 through 1972, and X is the number of years after 1957. So that's the initial year. So in that initial year, it is key to understand that it was $206 in the bank account. This is growth because B is greater than 1. So when B is greater than 1, that is growth. Okay. When B is between 0 and 1, that is, sorry about that, that is decay. Okay. So we know that this is growth. We know that X is our input, and that is going to be 5 because it says f of 5. Remember, function notation will be f of X. So f of 5 means 5 is our input. So it's 5 years because it says X is the number of years. So any answer that does not involve 5 years or involves, like, let's say $5, we know that that's incorrect. So look at letter A. $5 greater. That's not going to be correct. If I kind of scan my other answers, I can see C. Now, C says 5 times greater. We know if we're going from 206 to 243, that's not 5 times. 206 times 5 is not 243. So we know that C is incorrect. So I got either B or D. Let's read both. B, the value of the bank account is estimated to be approximately $243 in 1962. D, the value of the bank account is estimated to increase by approximately $243 every 5 years between 1957 and 1972. Okay, so with this one, let's analyze. If I look at B, it says that in 1962, I'll be at $243. So let's see if I subtract. If I subtract 1962 minus 1957, I indeed get 5 years. So it looks like that may be our correct answer, but let's look at D just to make sure. It talks about the value increasing $243 every 4 years. Well, if it was a constant rate of change, it would be linear, not exponential. So we know the answer has to be B. We did process of elimination. You always want to look at all your answer choices when you have multiple choice and then do process of elimination. Okay. So that was pretty decent. The next one we have to actually calculate. The function f is defined by f of x equals 270 times zero point 0.1 to the x power. What is the value of f of 0? So we know that 0 here is our x, that's our input. So we know we have to input 0 wherever we see x. So we're going to go ahead and do that. Now you can put this in your calculator, or you could just apply the rules of exponents, the laws of exponents. Anything to the zero power is 1. Now be careful because a couple of trick answers. You can think, oh, this is all raised to the zero power, but it's not. Only the zero point 0.1 is raised to the zero power. So I have to bring down my 270. When I have my parentheses and a number, that's multiplication. So I'm gonna go ahead and do a little multiplication here times 1. 270 times 1 is 270. So that could be a trick answer, that number 1. Also, 0 could be a trick answer because if you're asking about the input is 0, but they didn't ask you about the input. Output is always the f of x, or in this case, f of 0. So be careful of A and B as trick answers. Last but not least for this slide, 23. The function f gives the value in dollars of a certain piece of equipment after X months of use. If the value of the equipment decreases each year by P% of its value the preceding year, what is the value of P? Good question. So with this one, you could get caught up in the fact that you have X over 12 as your exponent. You really don't even need to mess with that. All you need to mess with is our B. So in this case, B is 0.64. As we talked about before, that is decay. That's definitely decay. And it says it's decreasing each year. So I have to find the percent of decay. When I have B and I want to find the percent of growth or decay, it's really not that hard. So for example, the percent for growth is I would take that number that they give us for B and I would subtract it subtract 1 from it. So let's say as an example, it was B was 1.8. Then I would say 1.8 minus 1 is zero point 0.8. So that'd be 80% growth. Okay. So that's just a little bubble there for growth. But what we really want is decay, right? So when we look at decay, we're going to do the same thing, but for percent decay, we're going to do very similar. We're just going to say 1 minus B. So in this case, 1 minus 0.64 gives me 0.36, and that's going to be 36%. So to find percent decay, you're going to say 1 minus B and then turn your decimal into a percent, and you would get 36%. And that is going to be your answer. So hopefully this will help you with the exponential functions. I'm going to do another one with one that's a little more complex, but I know we got it. We can do this. All right. I'll talk to y'all later. Peace.